let's say we have a large database, not those short little lists that we were scatter plotting yesterday, but we have a big, long, large database that is all of the scores on physics and calculus exams for all of the students across the entire state. That's a lot of scores. And we wanted to see if there was a correlation between those two scores. We do not want to plot all of the students' individual scores by hand onto a scatter plot to see if it makes a line or not. That would take forever. Yeah. So what tools can we use to find out this information in an efficient way? Well, hey, guess what tools we can use? Math. Yay, math. We are going to use the correlation coefficient and the coefficient of determination, and we will also be using linear regression equations. Okay, the linear regression equation will tell us, allow us to make predictions, and then the correlation coefficient and the coefficient of determination tells us about the correlation levels. Like whether or not they're correlated and how much so. Okay, so the correlation coefficient is a number that gives us a quantitative measure. Right? Numbers are quantitative of how correlated data is. Okay, you know how when we look at the picture, you can have a strong positive, strong negative, weak positive, weak negative by looking at the picture. Well, this is a number that will allow us to know if it's strong or weak. Okay, it's between -1 and 1. Okay, so negative, positive. The closer to 1 or -1, the stronger the correlation. Yeah, 0 equals no correlation. Yeah, negative is a negative. Like if it's -1, it's strong, like a strong negative correlation. If it's 1, it's a strong positive correlation. If it's 0, there's no correlation at all. Okay. And then the coefficient of determination, which is where we take the correlation coefficient, which is R, and we square it. So just whatever you get for R, you just square it. This shows how well the data fits the model. Oops. So you know how you were drawing that line of best fit? Well, the linear regression equation is the equation of the line of best fit. And the coefficient of determination tells us how closely that line models the data. So how accurate is that line, basically? That's what that tells us. So how accurate the line. And that line is called the statistical model. And if R squared equals 1, that's an R, that's an F, we have a perfect fit. Okay, it's a perfect model. It's awesome. Okay, if R squared equals 2, equals 0, we have no fit. So the model is not demonstrating, it's not working at all. Okay, and so R squared is between 0 and 1 only. And the reason that happens is because it's the correlation coefficient squared, which is between -1 and 1. And so you can't, if you square any of the negatives, you're going to get positives. And so you can only be between 0 and 1. Does that make sense? Yes, quantitative measure. this table, and this is only 9 students. This is the same example we used. We already graphed this one. So if, you know, remember we graphed that yesterday? Okay, so we've already graphed it, and we determined that it was a medium level positive. It wasn't super strong, but it wasn't weak. You know, it was in the middle. So what we're going to do now, we're not going to use, see how it says calculator? We don't have the good calculators that will do this. I'm not talking about you. The rest of us are going to use a website. And the website we're going to use is www.alca.com/statistics/linear-regression. And I tested out several calculators online, and this one is the easiest to use and gives you everything we need. Okay, so give me a second and I'm going to pull that up. Our data. And there are 2 ways to enter the data on here. You can do like a row of X's and then a row of Y's. But I don't recommend that because if you miss one, it's going to mess everything up. The X and Y's have to go together. So what I recommend doing is entering them as pairs. So my first one was 49 for X and 29 for Y, and then press enter. So you enter ordered pairs down, and that way you can make sure you line everything up well. And you, oops, unless you don't hit enter. Click submit data. Now, this gives us our sample size, which was 8. We have our mean. Our average was 49.375 for X, so that's the average for X. We have the average for Y, which is 29. We have the intercept. We have the slope, and it gives us the linear regression equation. It did not round very much. You do not have to write down all of these digits. Give me like 4. Okay, so what we'll write down is our linear regression equation, which is y equals negative 1 point, actually I only wrote down 2, minus 35.26. So negative 1.3x, sorry, no negative. Y equals 1.3x minus 35.26, right here. Okay, that's my linear regression equation. Now, see down here, it says use the linear regression equation to estimate y. We want to estimate that math test. I just put in 53, and it will do it for me. 33.7. Okay. Yeah, sure can. We'll do more. So far, okay? Now, I want to go to the next slide. If we want to determine the correlation coefficient and the coefficient of determination from that same set of data. Now, you'll notice when we were on here, it's not listed up here. But down here, click correlation coefficient. Scroll down as soon as it loads. Okay, scroll down. Oh, why is it not doing it? So it gave us the correlation coefficient. Again, do four digits on these. So 0.9486. So our correlation coefficient is 0.9486. That's R. It's close to 1. Wouldn't you guys agree that's pretty close to 1? This is a strong, positive.
So if it's like a 0.5, would you consider it medium?
Yeah, I would say so. I would say anything below 0.5 is going to be weak, and anything above 0.5 would be strong. Yeah. Now, R squared, that's our coefficient of determination. That's going to tell us how well does our model fit. We take R and we square it. And that is going to be 0.8998, which is also pretty close to 1. So this is a good fit. Our model fits our data very well. So we can say with accuracy that this student is probably going to get right around this score on their math. Somewhere right around there. It's going to be pretty accurate. That's what this tells us, that our predictions are accurate. Or they're not maybe necessarily perfect because it's not a 1, but it's going to be pretty accurate. Any questions about that? We'll go back to our thing. I'm going to reset my calculator. And I'm going to enter my new data, which is for the speed of a car versus its fuel efficiency, and we're going to see if there's any correlation. I'm going to go ahead and go out on a limb and say yes. Yeah. So my first one is 32 miles per hour gives me 40 miles to the gallon. My next one is 64 miles per hour gives me 27. 77, 24. 42, 37. 82, 22. 57, 36, and 72, 28. Submit my data. All right, I was on the correlation coefficient screen, so I got that number first, which is B. So R is negative 0.9535. Okay. And it's negative, so it is a strong negative correlation. Okay. Now if I come back and I go to my linear regression, it's giving me my scatter plot already. It's giving me my averages, and my equation is y is equal to 52.64 minus 0.3626 x. Okay, and it doesn't matter if you put the x term first or the constant first. That's okay, it doesn't matter. Just so long as one's a number by itself and one's got an x on it. Okay, so this is the line of best fit. We can look at the picture of our scatter plot. Our coefficient tells us a strong negative. We can see it's a strong negative. Okay, we want to find out if it's a good fit, so we're going to take that negative 0.9535 and square it, which gives me 0.9091. This is a good fit. Okay. Again, use 0.5 as your, that's your halfway point between 0 and 1, right? So if it's above 0.5, it's a pretty good fit. If it's below 0.5, not so much. And if it's 0, it sucks, right? Okay. So here's what we can do. We can use our equation to make predictions. If a car were traveling at a speed of 47 miles per hour, 47 miles per hour is our x. What would the fuel efficiency be? Well, that one I can plug in right here. I can calculate y if I give x. So I just click calculate y, and I get 35.595, which would round to 35.6. So 35.6 miles per gallon. Okay. If I have a fuel efficiency of 29 miles per gallon, but that's y. Now you'll see this calculator, the only thing it's not going to do for you is calculate y, x if you put in y. So we're going to have to do that the old-fashioned algebra way. So 29, that's y, equals 52.64 minus 0.3626x. So subtract 5264 from both sides. And you get that negative 2364 equals negative 0.3626x. And then we divide by negative 0.3626. Which I expect you guys to do with long division and show me all the steps. Okay, just kidding. 65.2 miles per hour. Okay, ready? Pie charts. Yay, pie chart. If you have $1,500 in your monthly budget and you need to spend 40% on housing and 20% on food and 10% on gas and other travel expenses and 15% on utilities and the rest on miscellaneous items, how would you represent that graphically? We don't want to do a line graph. That's not really going to visually. We're going to do a pie chart because pie charts are nice visual representation of how much of something is going to what. Because the pie wedges, the bigger the pie wedge, the more is going to that thing, right? So they're really nice for that. So this is the most effective way. To represent data as percents. Represent has a T. For what?
For the housing, $600.
No, that's pretty cheap. The circle represents the total amount. Okay. And the pie wedges or pizza slices, whatever you want to think of them as, represents the percents. And the hundreds wheel that I gave you makes creation easier. And I mean creation of a pie chart, not creation of like a new planets full of species. All right. Okay, so we take the first step. Step one is we need to find the total number of donors. Now this is very difficult. We have to add. Okay. Now the second thing we need to do is we need to find the percent of donors for each blood type. Okay, and for that we have to divide. So for type A, there were 7 people that had type A, so it's 7 divided by the total number, which is 25, which gives us 0.28 as our percent, or as our decimal, which gives us 28%. Divided 7 by the total number of people. So to find the percent, you do the part divided by the whole. Okay. And so then for B, it's 5 over 25 for type B, which gives me 0.2%, or 0.2, which is 20%. You always move 2 decimal places to convert from a decimal to a percent. So I go from here to here, here to there, and I have to add a 0. Type O was 9 over 25, which gives me 0.36, which is 36%. And then type AB, which is 4 out of the 25, which is 0.16, so 16%. Okay. From there, we will use the hundreds disc to create the pie chart. So I'm going to switch to the camera. So here's our disc, right? I'm going to draw a circle to make our pie chart. And I'm going to make it about the same size as the hundreds disc, but a little smaller. Like I said, you can borrow one of these if you want. I don't know. So, guys, shh. Oh, can you? Can you see it a little better there? Okay, guys, can you kind of see the little lines right around that? Shh. For a sec. Okay, so you're going to put your paper over your hundreds disc. And if you recall, our first percent was 28. So the long lines are 10. So here's 10, here's 20, and then the little lines are 8. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And probably I should have used a ruler to make that line straight. So there's my 28%. And that was type A. Okay. And then type B was 20%. So since that's an even tens, I'm going to go 2 over this way. And trace that line. Okay. Type O is 36%. So I've got 10, 20, 30, 1, 2, 3, 4, 5, 6. And then the rest is 16%, which if I look at this and I counted them, that would be 16%. So I have type AB is 16%. And I have an accurate pie chart that I didn't have to measure all the angles and calculate the percents based off the 360 degrees angles. This made it so I could just count. Well, sweetie, there's no such thing as a real perfect circle. It's theoretically perfect circles. So, but it's a pretty good circle. It's a nice circle. Okay. And then, you can put different colors on there if you want to differentiate between the different segments and make it all pretty if you want to. Okay. So any questions about how to use that? Okay. Oops. All right, so we've made our first pie chart. Making pie charts is only one of the things that we're going to have to do. We're also going to have to interpret pie charts. So here we have a pie chart about salad. Because only 10% of people like it. Yes. What salad is the most popular? Caesar salad. Okay. Which is the least popular? Taco salad is the least popular. Okay, guys. This is going to require some calculation. Okay. If 300 people are surveyed, how many people chose each type? Well, 35% of 300 chose Caesar, which is 105 people, times the percent times the total number of people. So 25% of 300 like the chef salad, which is 75 people. 13% of 300 like the garden salad, which is 39 people. 17% of 300 like the spinach salad, which is 51 people. And 10% like the taco salad, so 30 people liked taco salad. Okay, so that's how you figure out how many people liked or how much, if this was that budget question, how much money went to each. You just do the percent times the total. Okay, the difference between people who like spinach salad and people who like garden salad. Spinach is 51. Garden is 39. subtract them, that's 12 people difference.